Hi, this is Jim Oswald from Sierra Instruments, and I'm just going to show you a little bit about the CalTrak, how to use it, how to set it up, what it is. This is the base of the CalTrak. By the way, these are all packaged in a really nice case, which I encourage you to buy, called a Pelican case. And inside it's foam and the outside it's hard plastic, has wheels on it, and allows you to ship it back and forth for calibration when you do so, and also keep safe at your spot. Anyway, we've got this out of the case. This is a cell. This happens to be the -44 cell, which is the highest flow rate of the three. This one can go from 5 liters up to 50 liters. Then there's two that are smaller. It goes down to all the way down to 5 cc's. And this cell contains a puck. It's actually made of the material of the puck is the same as the material of the cylinder. And so they expand and contract together and they fit tight in there. It's mercury free. It's got a calculated leak. That's how it seals. And it's a very, very, very small leak in comparison with the flow rate. Anyway, there's sensors here, optical sensors, whatever, that determine its position. And that way, as it rises, it gives you a volume over time. So it's basically a volumetric standard. And it plugs into the base. The base contains the clock, pressure transducer, temperature transducer, and the electronics. So you buy a base and you buy 1, 2, or 3 cells. Like I said, this happens to be the 5 to 50. And I'm going to show you a little bit how to use it to calibrate. Okay, on the back of the CalTrak base, there's a couple connections. All I have here is the AC to DC converter plugged in. There's also an RS-232 connection, and we do supply a cable. You can write your own software. We have the command set for you to do so. There's a printer port as well. I'm not personally too familiar with that, but it's fairly straightforward. And like I said, this plug just sits down over here, and the back connection goes into this 9-pin D connector there. So now it's ready to go. The CalTrak is a true primary standard. It's not an inferential standard. It is a primary standard. And it's just like the bigger ones we use, very highly accurate ones that are floor mounted, but it's a nice desktop size and can be used for accurate calibrations and certifications. It's very rapid, very fast. The puck goes up and down in a very short period of time. I'll show you in a moment, but we can set the CalTrak to take averages from several samples and configure it many different ways. There's no mercury involved. The menus are pretty straightforward, pretty intuitive, and it's a very simple device to operate. So I'm not going to get into all the details. I want you to see how simple it really is to use. Just most simply, here is a controller, or actually it's a device under test in the center of your screen. You'll see a 1/4-inch line going into it, coming back out of it into the CalTrak. And then the CalTrak has a fitting on the other side of the cell that is just vented to room. That's the simplest way to use it. Upstream, again, from the device under test, another tube, and then either a needle valve, some kind of a way to control the flow. In this case, it's a mass flow controller. So what I'm going to do is dial in the flow with the mass flow controller. That is approximately what I want to see, and then I can forget it while I go over to my device under test and compare the readings there to the average readings that I'm getting on my CalTrak. Then I'll go back to my device under test and make the necessary adjustments until it agrees to my satisfaction with the CalTrak. This is one of the Sierra C100 series called the SmartTrak 2. And this one happens to be a unit that does not have a display on it. Not very interesting to look at, but the display is on a cable, and it is sitting here on the table. This is the pilot module for my controller, and to operate it, you press Well, let me get out first. Here's our flow screen telling us what kind of flow we have, 0 at this point. It's going to read air. It's in units of standard liters per minute. And when I press the enter button, it goes to a password. I'm going to go right past that to change set point. I'm going to press enter. I can change any digit I want. Let's go ahead and put in 5 liters, which is the bottom end of what this tube can do. And press enter again. I have compressed air hooked up to this, so now I'm passing, that's the set point. If I get back out, you'll see now I'm flowing about 5 liters. And it's going to go through the tube into the next device under test. Now this second device is a meter. It looks the same as a controller, but inside does not have a valve, so it's my device under test. I've dialed in my 5 liters, and now you'll see on my device under test, this meter is also reading about 5 liters, which it should agree, of course, unless it's out of calibration. Now from this, you follow the tube, then into, if I can adjust this camera, into the CalTrak. And now when I take some samples with the CalTrak, I can compare it to my device under test. Okay, now we have our CalTrak. We've got our 5 liters flowing from our controller through the device under test. We forget the controller at this point. We just compare the device under test to what the CalTrak tells us. And I'm going to tell you the menus here in a minute, but just simply right now I'm going to hit read. Let's see. There we go. And you'll see the puck going up 1 time. On the screen it tells me the flow rate that this CalTrak thinks or knows that I'm getting through my device under test. I can go back to my device under test and make any necessary adjustments. Now I just took 1 reading, and you just press read. Now that's how easy it is. I'm done taking a reading at that flow rate, unless I want to take several readings. And in this case, I've set up my CalTrak to take 5 readings, and I'm going to take an average. So I'm going to hit auto, and it'll just keep cycling every second. Oh, I guess I have it set up for 3. Anyway, I took 3, and I can read my average flow rate. And by the way, something here isn't set up quite right. This is a demo unit, and I don't have it dialed in to read correctly, but at least you're seeing how it works. I'll hit auto again. I really did have it set at 5, and this time it did 5 readings and took an average. I'll do that one more time, close up. And then you can see the polycarbonate piston rising and falling, taking samples, and venting the gas out of this fitting. Of course, you can vent it anywhere you'd like. The idea is to keep this at a fairly, don't pressurize this tube. Get a positive pressure coming in and vent to room, or you can use it with this fitting open and a suction from this side. This is the suction side, this is the positive pressure side. This is the in, this is the out. So you can plumb it several different ways, but this is the easiest way. Your CalTrak will come, once you power it on, it will come up to a main menu, as you see here, with several choices: run, setup, or leak test. I'm not going to go into the leak test now, but this has a feature where you can tip the cell upside down, connect a special cable that we provide on the bottom, and program this to do a leak test. And the unit will time the how long it takes for the piston to descend as it's leaking past the puck. And it will tell you whether it's passed the leak test or not. And I haven't had one fail ever. But here's the run menu. Well, let's go to the setup menu. Pressing the down button to set up, then enter. This is setup menu 1. Let me tell you just a couple of the important settings you'll want to make. There's only 3 or 4 to make, and then you're good to go. Sensor factor is essentially a K-factor provided by the manufacturer of the device under test for the particular gas. This comes up as a default of 1, which means you can use air or nitrogen, both are 1. If you're going to use some other gas and you want to basically fool the CalTrak into thinking it's helium or argon, then there would be a sensor factor you'd enter that the manufacturer of the device under test would provide. In our case, if you were flowing argon, this CalTrak would think it was nitrogen, so you'd need to enter a K factor or a sensor factor of 1.45, something like that, very close. Okay, but 1 is what you typically use, and by the way, air and nitrogen are the most common gases to use in the CalTrak. You can use other clean gases. You wouldn't probably want to use explosive gases, but if you had to, there is a special feature you can order called a purge feature, which provides you with a couple of fittings on the glass cylinder that allow you to circulate a purge gas during your testing, just in case there's an internal leak. But for our discussion today, we're just going to use a sensor factor of 1, and then you'll notice there's a cal type. Let's go to cal type and change from either standard, let's see, how do you change it, or volumetric. Those are your two choices. So at a push of a button, you can get volumetric flow if you're doing something like a nozzle or rotometer, some kind of a device that is designed to measure volume, or you can change to standardized or mass readings. So in which case the CalTrak will take the volumetric flow or the volume that it's measured and convert it into a mass, knowing which gas it's using, using the temperature and pressure transducers that are mounted inside. So you get a mass reading. Okay, let's leave it on standardized, that's most typical. And we'll go to the next menu. Menu 2. You can read in burst, number in the average 5, and minutes between readings 0. So it's going to pretty much immediately take 5 burst readings. Your options, burst meaning 5 in a row without, and then it'll stop. Your option there is continuous, let's see, continuous or burst. Continuous would just sit and run and run and run and run, but I think still, because you chose 5, it would average them every 5 readings. Okay, but it would continue to run. Sometimes it's a good way to exercise the device overnight or for a couple of hours if it needed to be purged. Okay, but I'm going to leave this in burst. Let's see, burst. I'm going to number in average. I'll choose 3 instead of 5. Let's see if I can figure out how to change the number. Well, I'll leave it at 5. Anyway, that can be changed to a number that you want it to average. Minutes between readings 0. Menu 3 is pressure units, temperature units in degrees centigrade. And here's an important thing to configure. Temperature correction. You have 2 choices, 21.1 C or 0 C. Let's see. Well, the 2 most common temperatures for your temperature correction will be 21.1 C, which is equivalent to 70 degrees Fahrenheit, or 0 centigrade. So those are the 2 choices. Actually, you want to be careful because when you get your CalTrak and first power it up, it will come up with a default of 0 degrees centigrade as your standardizing temperature. But you can put in any value that you want. Those are the 2 most common. But you want to check that because, for instance, the difference between 0 centigrade and 21 centigrade is about 7%. Sometimes I see people calling in about them not reading correctly, but that's the reason. So temperature correction is very important. Next menu, 4, gives you a chance to set the clock, check the voltage on your battery that's charging, and also a date and time stamp. Setup menu 5, date, time, and auto off, which is now enabled, so the CalTrak will shut off after a certain period of time. Setup menu 6 has a tare value and some other values that you use for your leak testing. And that's it. So you're back to your menus. You press enter for run. It comes up with a screen telling you your temperature and your pressure, your standardized temperature, your gas correction factor, the units you're measuring in, and then you just either hit read or auto. So if I do read, it's going to take 1 reading. If I do auto, it's going to take 5 and average them. You can do up to 100 readings and make an average. And so I've showed you the way to plumb the CalTrak is to put a controller or a valve first in line after your gas regulator. Let that create your flow through your device under test and out of that into the CalTrak and then venting into the room. And then once you start your readings, you're going to compare what you get on your primary standard, the CalTrak, to your device under test. Of course, you're going to believe your CalTrak and you're going to adjust your device under test to match and then produce your own certificate. Sierra will sell you a package with a CalTrak and an appropriate range controller. Each cell that you buy for a CalTrak can come with a controller. So you'd have a set of 3 controllers and a little manifold and your 3 different cells, and you could cover all the way from 5 cc's up to 50 liters of flow. We also make a CalTrak XL. Goes from 5 liters up to 500 liters. So it's a big one. So it substitutes for the old style bell provers. Just as accurate, but much easier to use, up to 500 liters. Plumbing, you want to minimize your dead space. Basic setup, allow enough time for this CalTrak to stabilize. Allow your CalTrak enough time to stabilize in terms of temperature in your lab. The bottom is an aluminum piece and needs to come up to temperature. You set your cal type for standardized if you want to do mass flow, or volume for volumetric flow. Make sure your temperature correction is set to the desired standardized temperature if you're going to do mass flow. And then the only other questions you might have is, can I use another gas during calibration? Yes, you can. And if your device under test and your CalTrak are both seeing the same gas, you could leave your correction factor at 1. However, if you're flowing, I know this is a little confusing. A couple of questions you might have. How do I correct if I'm calibrating my device under test for a gas other than nitrogen, but I'm using nitrogen as my test gas? That is when you use the K factor and you enter it as a gas constant into the CalTrak to make a multiplication. Or a second question, if I'm using a test gas other than nitrogen, what do I need to do to correct in the CalTrak? No corrections needed unless the flow rate is near the bottom of the cell's capacity. In that case, there is a leakage correction factor that you determine and you enter into the CalTrak, because each gas has a little bit of a different viscosity and way that it leaks around the piston. So that's basically it for the CalTrak. Have fun. Call us at Sierra Instruments if you have any questions.